Hello everyone, how are you doing today? It's our fourth class and let's get started. Today we'll be working with tools like Confluence and Jira. Not actually today, we'll be working with them throughout the course. So you will need to know about this platform and you don't need to worry because we'll guide you through every step and I will show you how to use these tools effectively. Okay, now the features of Confluence may vary slightly from company to company, but the components will be all same. It's a collaborative tool to document problems and solutions, and you will know its usage as we move forward. So when it comes to programming, some of you may find Java is easier than Python, or it can vary depending on your comfort zone. If you have a good command in Java, learning Python will be much easier. For this course, we'll focus on Selenium with Java, and we'll also get exposure to different kinds of programming languages. So if you have any problem or challenges, you don't need to hesitate to ask. You will get comfortable as we move further down the road. So now let's talk about the Scrum teams. Scrum teams. In the Agile project management framework, a Scrum team is different individuals working together towards a common goal, which is developing and delivering a product. So the goal is to develop and deliver. So it's the goal. Now the team typically have developers, then testers, then Scrum Master, and then product manager, and project manager, and business analyst. So the developers are usually responsible for coding. The testers are usually you, the role of you, many of you are training for. The Scrum Master ensures the Scrum process is followed. Then the product owner, they represent the client's interest. And at last, the project managers and business analysts. Their job is to help keep everything on track. Each member here I talked about plays a specific role, but collectively they work together to build, test the product to the market. Their ultimate goal is to deliver high quality software. So, what is the Scrum team's goal? The Scrum team uses defined principles, tools, and resources to ensure the product is working efficiently. The goal is not just to build the software, but ensure that it meets users' requirement. So let's go to the process once again, but this time in more details. My goal is for you to have a thorough understanding, moving to the next topic so that there are no confusions. So let's go step by step. The first step is CRS. The journey begins with the client requirement specifications or CRS. This is where this is the phase where the client outlines what they want in the product. It serves as a foundation of all feature documents and development. So it outlines and it is a foundation. Think of it as a wish list provided by the client. It may be sometimes high level and sometimes the core business needs. Okay? Then the next step is SRS and FRD. So the system requirement specification or the SRS is the translation of the client's business requirement. And the functional requirement document, it outlines the specific functional the product must need. So these documents are collaboratively prepared by the business people and the product owner. Okay, so it is usually prepared by the business people and the product owner. Prepared by the business people plus product owner. They form a bridge between the client's vision and the developer's execution. Okay, so it not just have the vision but also the developer's execution. Vision plus execution. Now let's talk about the product backlog. After defining the technical and functional needs, the product backlog is created. The backlog contains a prioritizing list of all features and functionalities to be developed. So it contains a prioritized list. It also acts as a living document that evolves as the project progresses. So as the project progresses, it gets updated and changed many times. Then comes business requirement specification. or BRS. The business requirement specifications is the next crucial document. It is usually written in work format and prepared by the business analyst. Work format prepared by business analyst. It has three key components, okay? The first one is objective. The second one is functional features. And the third one is requirements. So it has the objectives of the project, the functional features of the product, and the requirements needed to meet the business goal. Now the BRS, the responsibility of BRS is it ensures everyone's involved, the developers plus the testers plus the stakeholders. It ensures that each of them has a clear understanding of the business perspective. Then once the BRS is prepared, the business analyst presents it to the product owner and the project manager for its approval. Their job is to evaluate and provide their green light. So once it's approved, the BRS is ready to be handed over to the Scrum Master. He facilitates further process. So after the BRS and the inspections, it goes to the pre-refinement process. So in the pre-refinement process, the Scrum Master initiates this process. It is the first step toward breaking down the requirements into actionable tasks. So the after the BRS here, the BRS is refined and becomes SMART, SMART. It's not a single word. Each of the letter has a different meaning. So the S stands for specific. The M is for measurable. The A is achievable. The R is relevant. The T is testable. So SMART means specific, measurable, achievable, relevant, and testable. During this session, user stories are defined, then the scenarios and the acceptance criteria are discussed in detail. The goal here is to ensure that the requirements are clear, realistic, and actionable for the development team. Okay, understand so far? Now, the next process. The next process is, excuse me, is called priority and severity. Another key aspect of this session is determining the priority and the severity of each user story. For priority, it is the how important is the task from the customer's perspective. The priority is from it is for the importance of the task. For example, a login feature is a high priority because the customers need it to gain access to the product. And the severity is how badly does an issue affect the system or business operation. So, for example, a critical bug in the payment system could have high severity because it hinders the payment system for the customer to buy the product. So, in simple terms, priority is how soon do we need to fix this, and the severity is how bad is the problem. Then, before moving to the refinement session, there is a 2 week period. Okay, 2 weeks. So, in this 2 week, 2 week period is dedicated to different walkthrough meetings between developers and testers. The meetings are usually informal and focused on time frame and resource and tools. So the meeting is focused on time frame and resources and tools. The time frame is for how much time will each phase of development and testing will require, and for research and tools, what tools and resources will be used. For example, developers might estimate 7 days to code a feature, while the testers may need 5 days to test it. This collaborative planning ensures everyone is on the same page before the refinement session. So the developers and testers they need to work together to figure out a correct time frame for this project. Then comes the refinement session. The refinement session is where the team officially declares their effort estimation. Now, what is effort estimation? The effort estimation, the effort estimation is the relative time and effort required to complete a task. So it has time plus effort. The developers and testers finalize the time frame and justify why they need that time. So if they need 2 days or 3 days, they need to figure out why do they need those days and divide their work. Additionally, the test strategy, which outlines how testing will be conducted, keeps getting updated throughout this phase. Then comes the sprint planning. After refinement, we move on to sprint planning. Planning is a time-boxed event in the Scrum framework, lasting 2 to 4 weeks per sprint. So 2 or 4 weeks per sprint. During this event, the team decides which user stories or tasks will be deployed first. So here tasks are prioritized based on the importance and dependencies. For example, let me give you an example. In Sprint 1, the login feature might be prioritized because it's essential for all subsequent functionalities. In later sprints, the least critical features like contact us must be developed. The goal here is to establish a clear roadmap for development with the sprint. So to summarize, we have first the CRS, then the the SRS and FRD. So first, the client outlines their need on CRS. Then in the BRS and FRD, the technical and functional requirements are defined. After that comes product backlog. Here the features and the functionalities are listed. Then in BRS, the business analysts prepare the business requirement specifications. Then comes the approval process, where the BRS is approved by the product owner and project manager. Then comes the pre-refinement session. Here the BRS becomes smart and priority severity is determined. Then comes the walkthrough. It is usually when the developers and testers discuss their time frame, tools, and resources. Then comes the refinement session, where the effort estimation is finalized. Then comes sprint planning, where the tasks are prioritized and development order is set. So I organize them in a flow. Now, let me elaborate further with even more detail and step by step. So, in sprint planning and feature prioritization, sprint planning is the first step in agile development. Here, the team collaborates to decide which features and tasks will be developed in the upcoming sprint. For example, if your application has a contact us, and login functionality, the login feature is prioritized because it enables the access to the application for the user. So it has the first priority. Then the contact us is the less critical features that can be kept for the later sprints. During planning, each feature or task is divided into smaller units called user stories for better clarity and tracking. Then the development begins in the dev environment. Here the developer it begins in the dev environment. And the developers write code and deploy it in the dev environment. So code is written and deployed. After deployment, a URL is generated that allows the team to access and test the feature. Let's say a login page is developed. So as a specific URL is created where the login feature can be tested by the testers. Now they share their progress via Confluence. Developers document the feature URLs in a collaboration tool like Confluence. This ensures that everyone on the team, especially the testers, knows where to access the developed feature for verification. Here, the communication is the important key. The developers notify testers, typically via email or Slack, that the feature is ready for testing. Now, the testing in the developer environment, the testers use the provided URL to verify the functionality and identify any defects or bugs. So they verify and identify. If there are no defects, the feature is marked as passed and ready to move on to the next phase. So, if there are no defects, so it is passed. And if there are defects, the feature marked as failed and the issue is sent back to the developers to fix. So if the found defect, then it goes as failed. The iterative process ensures the product is polished before proceeding. Before the coding begins, architects prepare a design document. Design document. It acts as a blueprint. It specifies the tools and resources the developers needs and the architectural structure of the system. Okay. The developers rely heavily on this document during the coding phase. Although you as a tester Don't need to, you as a tester don't need to work on designs. Understanding its role gives you context about how the system works. Now about Agile methodology. Agile is usually all about flexibility and iterations. So it is about flexibility and iteration. While one sprint focuses on certain user stories, the business analyst and stakeholder works on preparing new stories for upcoming sprints. This ensures a continuous cycle of development and refinement. For example, in sprint 1, the team develops the login and sign up features. In sprint 1, login and sign up features. Meanwhile, user stories for profile management and forgot password are featured in sprint 2. Profile management and forgot password. This overlapping of tasks and preparation allows for faster and more adaptable progress. Uh, think of the system as a remote and TV. The remote represents the user's interface. It is user interface, and the TV, it is the backend. We usually interact with the remote and do use it to control the TV. The user usually interacts with the user interface, and in the backend, the process happens. The invisible connection is called the API. The connection between these two is called API. When you press the button, the remote sends a request to change the channel. The TV processes the request and performs the action. The response is visible to the user. In software, the front end or the UI sends the request and the backend processes and sends the response. So it sends request, it response. Now let's talk about what is GUI or graphics user interface. Do you know Amazon, right? It has buttons, menus, and visuals that users interact with. Like if you click on today's deals, it opens a page with deals. It is called the graphical user interface. And for browser functionalities, features like bookmarks, address bar, and tabs provided by the browser itself. Okay, it is not part of a web page. Understanding the distinctions help the testers focus on what needs to be tested on the web page, and the browser level interactions. Now let's talk about API. Imagine you are shopping in a store like Walmart. You want a phone with specific features. The store assistant takes your request and goes to the storeroom to fetch the mobile. Then brings this item and gives you, and you make your choice. Here, you are the end user. The store assistant is the API, and the storeroom is the back end. So you are user interface. The store assistant is the API, and the storeroom is the database or backend. The API acts as a middleman to ensure seamless communication between the front end and the back end. So this process of planning, development, and testing and refinement under the Agile is iterative. Here, the API plays a crucial role in facilitating communication between different components of the system. The testing ensures that every interaction, be it user clicks or backend responses, function smoothly. Okay. Now let's dive into today's specific topics and build its knowledge. If you have any question or if you think any part is unclear, you can ask me. The application program interface or the API, as I've talked, acts as a bridge between the front end and the back end of the product. It ensures seamless communication between these components. Let's take an example of a e-commerce website where the customer logs into their account. The database stores and retrieves the customer's details such as name, email, login credential. The API ensures that the information flows correctly between the database and front end. It ensures database plus front end. This process ensures that when the customers revisits the website, their information is readily available without any issues. Now, understanding front end and back end. What is front end? Front end is usually the graphical user interface. It refers to what you see and interact with, like buttons, image, or text on a web page. Whereas in the back end, it refers to process running behind the scenes, like the database operations or the API requests. Both the API and database work here. As a tester, your job is to ensure that the API works as expected. Okay, you need to figure out that about their response and functionality. For example, if you click a mobile category, the API should only load the mobile related products. If it loads unrelated items like the bags or cosmetics, there is something wrong in the API. And for the functionality check, the testers verify that if the API correctly follows the user's command. In order to test an API, you can use browser developer tools. Like you open a DevTools in Google Chrome, you can click on any website, a web page, and click inspect or inspect elements. Here, a panel opens with various tabs like elements, console, network, etc. Then you can go to the network tab to track the API activity, and you can perform an action like select the best sellers category. This triggers the API request and you will see the list of the network. Then to check the API response, you look into the request URL to confirm the page is being accessed. Then you verify the request method like get, post, and check the status code. If you see number 200, it means that the API is working correctly. So it means it is working. And above 200, it has potential issues, especially with rate indicators like 404, not found, or server error, something like that. Now, let's talk about HTML. The panel that opens the DevTools is called the HTML DOM or Document Object Model Structure in the developers tool. It usually displays tree like the structure of HTML that developers use to build and style a web page. Testers need to verify the API's functionality and how the front end interacts with it. Now, for building a websites evolves gradually. For example, the developers create basic features like login, registration. Then over time, they add more features like shopping, cart, or product categories. The front-end design improves to offer a better user experience. So the key points to remember while testing for API, always check the request URL and status code. At 200 status code means the API is functioning correctly. Anything else is usually signals an issue to investigate. You can use dev tools or specialized testing tools like Postman for in-depth API analysis. Now let's break down how things work behind the scenes in web development and testing. For example, imagine you are clicking on a page and it takes you to a new page. Do you know what's happening in the backend? Do you know the code the developers have written to make it work? Probably not. But let's explore how you can understand this process better. So the development source code or develop document object model is DOM is the developer's document for users. It's usually the developer's source code. The instruction it is the instruction that the developers write using a specific framework to build the functionality we see on the front end. One popular framework is Angular. Developers write the application's code using Angular, which controls how elements appear and function on the web page. However, as a tester, you won't always have to access to the source code. Your job is to test the front end, front end, the visible part of the website to ensure everything is working as expected. Let's imagine a scenario where the tester has gone on vacation and asked the developer to test login feature on their behalf. The developer agrees and goes ahead to perform the test. Now, what is happening here? The developer, being familiar with the code, not only writes it but also tests it. As the developer knows the internal working of the code, they can perform what is known as white box testing. But what if the tester learns the internal logic from the developer? Can the testers then run tests the same way? Yes, exactly. If the tester understands the code and the logic behind it, they can also test the white box testing. The key point is that the white box testing happens when you understand an internal code and logic of the system. So let's talk about white and black box. The white box testing is who does it, then why, then what. You need to answer these three for both the white and the black box. So in the case of white box, who does it means the developers and testers who understand the internal code. And why does it? Because they know the logic and structure behind the code. And what is tested the test functions are the internal functions, system design, and the implementation details. For the black box testing, who does it is actually the testers does it. And why? Because the testers don't know the internal workings of the system. And what is tested? The functionality of the application, like ensuring the login button works or checking the overall user experience. In black box testing, the tester doesn't need to know about how the system works internally. For example, when testing an e-commerce site like Amazon, a tester would click the login button and check whether it's clickable or and ensure the page loads correctly. They don't know the code behind it, so they just know that it works as expected. So, to understand the black box scenario, suppose suppose the user clicks on the books on Amazon. The expected output should be the page displays books that the user can browse. So for testing, the tester need to open and go to Amazon. Then go to menu and click on books. The result should be the testing. A tester is checking if the books page loads, but they don't need to know the internal code behind it. In this case, the tester only sees the test case output, whether the books page loads successfully or not, but they don't know the internal working of the backend system. So this is called the black box. So it focuses on the results. When the developer work on the back end, they typically start by testing small individual parts of the component. This is called unit testing. For example, a developer might write code to create a button called bestsellers on Amazon page. Then test its functionality. This is unit testing individual pieces of code. Individual pieces of code. Now let's talk about the component testing. The component testing happens when the testers check specific components or features like bestsellers button to ensure they work properly. The testers focus on individual elements like ensuring the button displays correctly and is functional, but they don't dive into the actual code. So for unit testing, it tests small parts. For component testing, specific features. In some testing cases, there is a middle ground. It is called the gray box testing. It is called the gray box testing. It is usually for the senior QA testers who have partial knowledge of the internal code. For instance, if a senior tester has a basic understanding of HTML or the internal code but doesn't know about all the details, they can run tests that bridge the gap between white box and black box. It is usually a combination of both. The testers might have the partial knowledge of the code or the system, allowing them to perform specific tests like about the login, like checking the login functionality. So to sum up, the white box testing is for the user who have who understand the internal code, usually the developers. The black box testing is for the testers who focus on functionality without knowing the backend code. And the gray box testing is for the testers with the partial knowledge of the code. By understanding these different types of testing, we can appreciate how each plays a crucial role to ensure software quality and functionality. Now let's go through some fundamental concepts in software testing. Now I want you to think about a developer for a second. Imagine they've just finished the pen body for a new pen product. What happens next? Well, after the developer completes this, they test it themselves. This is called the unit testing. So why unit testing? Because the developer is testing a single unit of the code. In this case, the pen body. It is all about testing individual components, usually by the developers themselves, to make sure that each part of the code works as expected. It is focused on the smallest part of the functionality before it gets integrated into the larger system. Now, when the tester comes in, things change a little bit. Okay? If a tester were to check the individual parts, let's say about the pen body or the pen cap, for the first time, they would do component testing. The key difference here is that while the developer is focused on the code, the tester is focused on how the feature behaves as a standalone component without looking into the internal code. The component testing is essentially a form of testing individual units of the product, but from the tester's perspective. Let's say the developer finishes testing the cap and the pen body individually. Now they integrate these two parts, the cap plus the body together. So it is the pen. It's called the integration testing. What's an integration testing? It's when the two or more parts of the system are brought together and you test whether they function correctly as a whole. For example, when the pen cap and pen body comes together, we need to ensure that they fit perfectly. The process ensures that all parts work together as expected, whether it's different components in the code or the physical product like a pen. Now, testers, once the developer has integrated the components, will run the tests again. This is where we talk about the regression testing. Regression testing is when you test the old features to make sure that the new changes or additions haven't broken any existing functionality. Think about it like this. If you have tested the pen cap separately and the body separately, now they're together. Regression testing ensures that both parts still work well independently and together. Let me give you an example. When a tester checks the functionality of a login button or a card, these are the two buttons. When a tester checks them, they are performing the black box testing. They don't care about the internal working of the code. They are simply testing what happens when the user interacts with the interface. But happens when the developer knows the internal code and the logic behind each component? That's when we are talking about the white box testing. Developers often perform white box testing before they have access to the code and they know exactly how it's functioning internally. It's a bit like knowing the inner mechanics of the pen, every little detail. On the other hand, testers often focus on black box testing, where they just look at the inputs and outputs. They might test the user interface, the look and feel of the application, but they don't need to understand the underlying logic or the code that's running the application. Now, let's say you are working in a gray box testing. This is a combination of both black box and white box. A tester with partial knowledge of the internal workings of the code, like knowing how the login functionality is coded, might use both testing approaches. It is useful for testers as they test new features with some insight into the development process. Imagine the development process goes in stages. First, you have created a feature like registration page. Now it's time to integrate the registration page with the login page. Reg page plus log. For this, you perform the integration testing. This ensures that all parts of the system, like the registration form, the login button, or any additional features like forgot password, they all work together. As we move from one testing stage to another, developers continue to build and integrate features. What happens when all the individual features are tested and integrated? That's when we enter the system integration testing, or SIT. In this phase, we connect all the components of the system and ensure they function together as a complete product. Now, there are two approaches for system integration testing. One is incremental, and the second is non-incremental. In incremental approach, it integrates and tests component one at a time. It's like building a pen, testing the cap first, then adding the body, and then again testing it. If something goes wrong, they can fix it immediately before moving on to the next stage. It helps to identify bugs early and prevent them from affecting the later stages. It's a more flexible approach. And in the non-incremental approach, it involves testing everything all at once. You build the cap, the body, and the ballpoint together and integrate them all together at the end. The downside is if something doesn't fit or doesn't work as expected, it can be hard to track down exactly where the problem lies. It's a more rigid approach, and debugging here is more challenging. So the system integration testing happens when all the components are together integrated in a testing environment, which is the SIT environment. The development phase or the dev environment is where you build and test individual component. After that, everything is integrated and tested as a whole into the SIT phase. The system integration testing ensures that every individual component works when combined. And the incremental integration approach makes sure that any issues are caught early, where the non-incremental integration approach tests everything all at once, but it is more challenging. So now you have a clear understanding of the unit testing, component testing, integration testing, regression testing, and system integration testing. You will know when to apply a black box, white box, or gray box testing. The difference between the incremental and non-incremental testing. If you have any questions, you feel free to reach out. It's crucial to understand this testing methodology to ensure we deliver a reliable product that works well with from the individual components all the way to the integrated system. So, um, here for the summary of the page of the testing phases, the unit testing is testing the individual units. Then component testing is for the testing. So that unit testing is for the developer. It tests individual units like the pen body and the cap separately. Then the component testing is for the testers. They test different parts together as a whole component. The integration testing is for the developer. They test the integration of different parts to check if they will work well together. And the regression testing is for the testers as they test the old parts again after new changes to ensure that nothing is broken. Now let's understand the basic concept of the two types of integration strategy. One is top-down and the other one is bottom-up. In the top-down integration, the development progresses from top of the system to the bottom. You start with the main or the higher level module and integrate them first. For example, let's say we're developing a website. In the first sprint, we create a registration page. In the second one, we develop the sign-in page. Then we integrate the sign-in page with the registration page and test it. This is called the top-down integration because the flow starts from the top of the uh, module, like the registration page, then goes down to the sign-in page. This method is often used in companies as it allows you to build up the system step by step. For the bottom-up strategy, you start with the lower level module and integrate upwards. For example, let's say while testing the shopping cart module, we start with it and then move on to the test home page, then the signing page. And finally, we integrate everything upwards. This is the bottom-up integration. So we move to the shopping cart to test the home page. This method can be used if the company prefers to start from the bottom-most features and work all their way up. So, in order to know when to use each integration module, the top-down module is useful when you have a clear sequence of features that need to be tested, and you want to ensure high level module integrates well before moving on to the next one. And in the bottom up integration, it is useful when the system is built in a way where the lower level components are already functional and you want to ensure their correctness before moving up the chain. Let's give an example of each of the modules. Okay. Suppose you create a registration page and in sprint 1, test it and integrate the signing page. In sprint 2, you continue integrating higher level features such as the home page in sprint 3 and finally the shopping cart in sprint 4. The flow moves from top to bottom. Okay. So in sprint registration page in sprint 1, then go to sign in, sprint 2, then all the way to shopping cart, sprint 4. It is the top-down model. And for the bottom up, you start with the shopping cart. In basically, it is all the way from here to here. You start with testing the shopping cart in sprint 4. After it's tested, you move on to the test the home page in sprint 3, then the sign-in page in sprint 2, and finally the registration page in sprint 1. The flow moves upward with each module. We, the flow moves upward with each module tested before moving on to them. So in conclusion, both top-down integration and the bottom-up integration have their merits, and the choice of which to use depends on the project requirements and the company preference. The developers conduct unit testing, integrate components, and check for any issues using either top-down or the bottom-up approaches. The testers, on the other hand, ensure that the new changes don't disrupt existing functionalities through regression testing. Lastly, I'll give you a brief comparison between Agile and waterfall methodology. Okay, so the waterfall is a linear approach where each phase must be completed before the next begins. It is usually rigid and doesn't allow changes once a phase is complete. So it is like a waterfall where each phase is dependent on each other. On the agile one, it is flexible and iterative. Here the team works on sprint and make changes throughout the development process. It is more suitable for long-term projects because it allows for continuous feedback and improvement. So it works on sprint 1, sprint 2. You understand both of these now? So that's all for today. Please review all the material and feel free to reach out if you have any questions or if you are stuck and need clarifications. You can contact me. And don't forget to go through the video and the slides. They will help you with these topics we've covered. So that's it for today. See you in the next class. Thank you.